All right, now that you're done with Chapter 9, we're going to review for the test. In Chapter 9, we started with 9.1, roster notation and set builder notation. So roster notation is a list. So this is the roster that belongs in Group B. 0, 1, 2, 3, 4, 5. It's just a list. Set builder is a description that describes that list. So for example, the B is, remember, x such that x is a whole number less than 6. So this described what was in this group. That's a description. Now with that information, now we were able to talk about what an intersection is. An intersection is what two sets have in common. So if we're looking at A and B, the intersection of A and B, what they have in common is they both have 1, they both have 2, and they both have 3. Now with intersection done, we have union. And union is all the members in both sets. And you only list the number one time, even if it comes up twice in both sets. So A and B, we take that same group we were just looking at, and we list all of them that have in common. So -2, and we try to put it in order. -2, -1, 0. And then we have 1, 2, 3. And then over here, we got 1, 2, 3. We only put it one time, but then we also have 4, 5, and 6. So a union altogether. Now that was section 9.1. So now let's talk about 9.2, and it's asking us to graph a conjunction. So we're looking at this, and remember that what you're looking at is there's no equal sign. So we have an open dot because there's no equal sign. It says x is greater than 5. So x is greater than 5 would be in this direction, and you just think about it, what's greater than 5? 6, 7, and 8, so forth. X is less than or equal to 12. So we're going to fill in that hole, and the stuff that's less than would go this way. Since we're looking for a conjunction, we want something that builds both of them answer. We're looking at right in here between the two. That's the conjunction, where it has true for both things. It's greater than 5 and less than or equal to 12. And they usually use the word and in between. So now if we're looking at a disjunction, we're looking at x is less than -3 or x is greater than 6. So we use the word or instead of and let's see what happens. So x is less than -3, open circle at the -3, and I know that it's less than, and less than goes this direction. X is greater than 6, open circle, and greater than 6 would be this way. You'll notice they do not come together. So we have to use the or because a number cannot be both of these things. It cannot be less than -3 and greater than 6. So again, we're looking for one that could be true for one or both, usually only true for one, and then they use the word or. All right, so now we're on to section 3 of 9, and that was where you looked at absolute value. And you know that what's inside this absolute value, if I put it in here, if I take the absolute value, I'm going to get 6. So the two things I could put inside here that would give me the answer of 6 is 6 or -6. So we take what's inside the absolute value, x plus 8, and we want to know when that equals 6, and then x plus 8 when it equals -6. So you're just going to solve. You want to get the x by itself. Plus 8, opposite is -8, both sides. So here I get my 0, and I'm just left with x is -2. And over here, I subtract the 8 from both sides. This does give me 0. I get x equals -14. So my two answers are x is -2 and -14. And then what you're going to do is do a check. So you're going to come back into the box here, into the problem here, and you're going to plug in -2. So -2 plus 8. 8 minus 2 is a 6. The absolute value of 6 is 6, so I know that this one works. I'm going to come over here and do the same thing for -14. And so we go in and we put negative 14 plus 8. I get negative 6. And the absolute value of negative 6 is 6. So these 2 points work. The answer is negative 2 and negative 14. All right, so now this one's a little more difficult because we have a number outside of the absolute value and then the numbers inside the absolute value. So the first thing we're going to do is we're going to solve and get the absolute value by itself. So we move this 5 by subtracting 5 from both sides. This gives me 0. This is a positive, so I don't really need to move that plus down. It just means that I'm looking at a positive. And now you know whatever's inside this absolute value, whatever it is, has to equal 2. So the absolute value of 2 would be 2, and the absolute value of negative 2 would be 2. So we want to know when this equals 2, and when does this equal negative 2. All right, so again, solving. We're looking at a plus 2, so the opposite of negative 2. This is 0, and we're left with 5x equals 2 minus 2, which is 0. I want to get rid of that 5. I'm going to divide both sides by 5, so x equals 0. So one of our answers is x equals 0. So now we come over here, we're going to do it again. Subtract the 2 from both sides. This equals 0. We're left with 5x equals negative 4. Multiplication, opposite operations, division. I get x equals negative 4 fifths. So now I'm going to do my check. I'm going to start with 0. So I go back to the very first problem, the original problem, and the original problem was 5 plus the absolute value of 5x plus 2 equals 7. And so I'm going to go in there, and everywhere that I have x, I'm going to put a 0. So 5 plus the absolute value of 5 times 0 plus 2 equals 7. And then what I get inside here is 0 plus 2, which is 2. And 5 plus the absolute value, the absolute value of 2 would be 2, and 5 plus 2 would be 7. So 0 did work. Now I know this one has a fraction, but it's not too scary. It'll kind of melt away there right off the bat. So 5 plus the absolute value of 5x plus 2 has to equal 7. We're going to plug in that variable, the answer for that variable, 5 times negative 4 over 5. And you should start to see, oh, that fraction is going to disappear really quickly. Here, when I do multiplication, remember there's always a number or 1 underneath that 5. 5 divided by 5 is 1, so I'm left with negative 4 divided by 1, which is negative 4. And the fraction's gone in the first step. 5 plus negative 4 plus 2 would be negative 2. And the absolute value of negative 2 is 2. And yes, it does work. So my answer is 0 and negative 4 fifths. Okay, so now we're looking at 9.4, inequalities and absolute value. So we're looking at the absolute value of 3x is less than 15. When we're solving these and we're working on these problems, we're going to rewrite it. And again, we're looking at, okay, what would be inside here? So what's inside here that's going to make it be less than 15 is going to be something less than 15. So we're looking at what happens when 3x is less than 15, and then the other one we're going to write is 3x is greater than negative 15. So looking back at your notes, remember that we keep it the same and just get rid of the absolute value. And then on this side we keep the 3x the same, but we switch the inequality and we see what happens when it's negative 15. So over here we're going to divide both sides by 3. X is less than 5. And then over here divide both sides by 3. X is greater than negative 5. So when we put this in a graph, here's negative 5. Here's positive 5. We notice that they're both open circles because they do not have an equal sign. X is less than 5, so that means we're looking at this way, and x is greater than negative 5, so we're looking between the two 5s, a conjunction. All right, let's try another one that's a little bit more difficult. So again, we're going to rewrite without the absolute value. Then we're going to rewrite without the absolute value change the sign to a less than instead of the equal to, a less than instead of a greater than, and then change the sign to a negative 16 instead of a positive 16. Keep the inside part here, get rid of the absolute value, keep everything the same. Get rid of the absolute value, switch the inequality, and change to a negative 16. So now we're going to solve it, and we're going to get that side with the x by itself. So we're going to subtract the 4 from both sides. So this is 0, and we're left with 2x is greater than or equal to 12. Divide by 2. X is greater than or equal to 6. Over here, we're going to subtract that 4 from both sides. This gives me a 0, and I'm left with 2x is less than or equal to negative 20. Divide by 2. X is less than or equal to negative 10. We go to graph that. We've got 0, 1, 2, 3, 4, 5. So way out here would be 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And negative 10 would be way out here. We're both situations, we're looking at a closed circle. There is an equal sign. We're looking for x that is greater than 6. Well, that would be this way. And x is less than 10. So we're looking at a disjunction here. We're coloring in this way, and we're coloring in this way. All right, so now we're looking at 9.5, inequalities in 2 variables, and we're going to be graphing. So now, when you have 2 variables, you're looking at graphing it on the plane and not on a number line. So let's go ahead and do that. When we're graphing, we're going to pick 3 numbers for x, and we're going to plug them in and see what happens. So first, we're going to treat it like an equal sign. We're going to plug in x is 0 and see what happens to y. So y minus 0 would be y, so we get 0. Plug in 2 times 1. Y minus 2 equals 0. Add 2 to both sides. Y equals positive 2. Y minus 2 times 2. Y minus 4. Add a 4 to both sides. Opposite operations. Y equals 4. All right, so now we have 0, 0, 1, 2, and 2, 4. It is going to be a solid line because there is an equal sign. Now we're going to substitute in to see which side we're going to shade in. 0, 0 is on the number or on the line, so I can't use it, but I'm going to try 1, 1 right here. 1, 1. I'm going to plug it into the problem up here, and I'm going to move it over just here a little bit. 1 minus 2 times 1, is it greater than 0? So I get 1 minus 2, and that's negative 1 is greater than 0, and that's not true. That's false. So I'm not shading in where the 1, 1 was on this side. I'm going to shade the other side in. So now 9.6 was graphing with systems of inequalities, and remember we're going to be looking at 2 or more equations when we're looking at that, or 2 more inequalities. So now we're going to go ahead and put the t-chart over here for this inequality, 0, 1, and 2, and we're going to put a t-chart over here for this inequality, 0, 1, and 2. We're now going to find out, we're going to treat it like an equal sign, so I'm going to move that sign, that problem down here as an equal sign and see what happens to the problem as we plug things in. So let's see what happens when x is 0. Y equals 4 minus 1, or excuse me, 0 minus 1, which is negative 1. Now we're going to plug it in again, except for this time we want to know what happens when it's 1. So y is 4 times 1 is 4 minus 1. Y is 3. And what happens when we plug in x is 2? So y equals 8 minus 1. Y equals 7. So now let's go ahead and graph the first one. 0, negative 1, 1, 3, and 2, 7. 7. It's going to be a dashed line. There's no equal sign here, so no solid line. You should also notice that 0, 0 is not on my line. It's off my line over here a little bit. So I'm going to plug in 0, 0 and see if it works. So I get 0 is greater than 0 minus 1. And 0 minus 1 is negative 1. That is truthful. So for this inequality, we're going to be shading in the region on the left side because the 0, 0 did work. So now let's go ahead and go and solve the other one. What happens when we say x is 0? Y equals 0 plus 3. So y equals 3. What happens when we say, oh, let's see what happens when x is 1. Y equals negative 2 plus 3, so y equals 1. And then the last one, what happens when x is 2? Negative 4 plus 3, y is negative 1. So now we go over here and we graph 0, 3, and 1, 1. And 2, negative 1. It's going to be a dashed line because there is no equal sign. Boom, 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 boom. 0, 0 is not on that line, so I can try 0, 0 to see if it works. Y is 0. X is 0. So in this case, I get 0 is less than 0 plus 3. And so I get 0 is less than 3, which is true. So 0, 0 is on this side of that line. So I'm going to shade in over here. The answer to my problem, the answer to the systems of equations, is where the two cross each other. So in this case, it crosses between here and here. So everything in this section and going that direction would then be part of that system of inequalities.